welcome to Chapter 8, and we are going to be transitioning from proofs, which you will still see them, but you are pretty much done having to write them. The book will have them in there, and you hopefully now know how to read a proof and know the purpose of one. Whether or not you enjoy them, that is another story. So we're moving into proofs, out of proofs into formula fun. We will have so many formulas we won't know what to do with ourselves, but starting with area formulas, obviously. And now we're on our first section of 8.1, which is titled The Meaning of Area. If you look at your book on page 310, it specifically, that very first paragraph talks about Revelation 21 and how in verse 27 they start to talk about how we are all written in the Lamb's Book of Life. If you also look at verses 16 and 17, the part that has to do with math that I want you to focus on is it talks about the volume of the city, the surface area of the city. Okay, why would the holy city be, its measurements be important? Okay, I want you to think about that. I want you to think about your answer to that. And if you can't come up with one on your own, I want you to even talk to your Bible teacher about that. Because I'm not going to answer that question in this slideshow right now. Okay, but I want you to think about it. So area, the concept of area is something we take for granted because we've been doing it since elementary school, but also volume and surface area have to do with area. They're concepts that build upon just the initial thing of area. Surface area is just the outside area of a 3D object, and then volume builds on that, adds another dimension, a 3 dimension. Okay, so the area of a region is the number of square units needed to cover it completely. The first postulate in our book on area is called the area postulate. Every region has an area given by a unique, positive, real number. The congruent regions postulate means that if two regions have the same area, then they're congruent, right? And then we have the area of square postulate. So the area of a square is area equals the side of the square, of the shape, squared. So side times side is s squared here in this formula here. So remember I told you we're going to start piling on some formulas. Okay, so I'm going to find the area of this square. The formula says that I need to know the side length of just one side of this square. Well, if I measure the units down, say side AB, it's 4 units. So I'm going to substitute 4 in for S and then square it. So I know that this area, the area of this square is 16 square units. Super important to know how to label your numbers. Okay, now these labels, the units, if they are naked and have no label, then you lose credit. Okay, it's not 100% wrong because obviously you did the correct math, but there is going to be points deducted for not having the proper label on your numbers. Okay, so no naked numbers. Okay, so we're going to find the area of this rectangle that measures 4 feet by 7 feet. So here's my 4 feet wide, and I have to go 7 feet across. So literally I am multiplying 4 times 7. That will give me how many square feet that I have. Okay, this is the last postulate that we're going to learn, there's one more theorem, but the area addition postulate is where you're going to do primarily most of your exercises in class. So if the interiors of two regions do not intersect, then the area of the union is the sum of their areas. This is especially helpful when I have very strange polygons, when I don't have a perfect square, I don't have a perfect rectangle, I have maybe a horseshoe shape. We're not talking about anything with arcs in them, okay? Not yet. So any pieces of a circle are not included yet. We're talking about figures that have a number of sides. Okay, so let's look at one. Okay, so the area, the theorem is next. The area of a rectangle is the product of its base and height. So we're going to multiply base times height. Now, you're used to calling this length times width, right? And that's what we did with the rectangle. That was 4 by 7 feet. We found out it was 28 square feet in area. Now we're talking about base and height. It's exactly the same thing. It's just different words, okay? And you have to get used to the new words because this is going to be helpful when we talk about area of a triangle. So just think about that rectangle sitting on one side. That would be its base. And then how tall it is would be its height. Alright, so let's practice finding the area of a rectangle. You can draw a picture for yourself if you like, but I would like you to hit pause, see if you get the right answer, because I'm testing your algebra skills to see if you remember how to multiply radicals. You notice there's no decimal point, no decimal places for your answer on 1 through 4. So hopefully we remembered that if I have two radicals, they're both inside a house, when I multiply them, I put them both in the house and I multiply them together. So 5 times 2 is 10. So the radical 2 times radical 5 is radical 10. Again, I want you to hit pause and see if you remember how to multiply binomials. Again, testing some of your previous algebra skills. This is FOIL for those of you who like that word. This is double distribution if you like that better. Okay, so hopefully you noticed this was a plus and a minus on the interior means that my answer will be a difference of 2 squares. Now we're going to use that area addition postulate. So I have 2 strategies that I can use whenever I want to use the area addition postulate. Okay, I can take this and look at it and pretend that middle section is there, right? And find the whole rectangle as if it were complete, and then subtract off what's not there. Or I can section off little rectangles all around the green area here and add them all up. So both are right, and you should get the same answer no matter which way you do it, as long as you are adding and subtracting correctly and you don't forget any pieces or do any overlapping areas. The trick is the overlapping thing, because you'll basically counting an area more than once. So I can divide this shape this way to where I have a little 1 by 4 piece in the middle, I have a little 2 by something piece there. We're going to have to decide how long that is, and then I'll have identical piece below, right? And then I've got my little 8 by something there, so we're going to have to decide how we're going to subtract off our pieces. Okay, I'm deciding that that is 8 for a base and 2 for a height. If you can follow along with me, the whole distance, right, the whole distance is 10, but if you look below, to the piece below, that little distance was 8. So I'm going to decide that the long, tall rectangle is only going to be 2 wide. So here's my 2 by 8, my 1 by 4, and my other 2 by 8. So that should be all my pieces. I drew the little dotted yellow lines to help keep track of how many pieces I actually have, and that way I don't count any twice. When I add them all up, I find that the area is 52 square units. Alright, so here's another example. The last one we did by adding up all of the area piece at a time. I want to do this one to where I find the whole area as if it were a complete shape, a complete square or rectangle, and then subtract off what's missing. So this one, if I continued on, this rectangle would be a 9 by 10. And then the piece that's missing is a 3 by 7. And so I'm going to subtract that off. Now if you're not sure how I knew that was a 3 in there, there's a 5 over on the left and a 2 on the right, and the whole top is, we're assuming, the same length as the bottom. So 10 subtract 7 gives me my 3. And then I get 69 meters squared. Let's do it where I use the area addition postulate, where I find each individually. And did I get the same answer? The answer is yes, I did. So no matter which way you like, both work, and you'll get the exact same answer and solution regardless of which way. You just have to make sure you are doing your math correctly. And another example. Feel free to pause if I'm going too fast. Add up all these pieces. And now I'm going to do the exact same problem with using subtraction. Okay, so I got the same answer both times. Okay, so for your WSQ summary, I want you to describe the following in your own words. I want you to describe area, the difference between area and perimeter. I know we did not talk about perimeter, I'm completely aware of that, but you already know what it is. The kind of units to measure area. Alright, and go ahead and submit those through email, and I will see you in class.